Hey everyone, today we're going to go over the minimum size subarray sum problem. So I just made a mock interview video for this one and I got like really stuck. I thought I had the right solution and basically I had the right solution, it was just that I read the problem wrong. So I'll first go over the problem so given an array of n positive integers and a positive integer s, find the minimum length of a contiguous subarray of which the sum is greater than or equal to s. If there isn't one, then return 0 instead. So I wasn't sure about what contiguous meant. Contiguous means the numbers are in a row, so like 4, 3, or like 2, 4, 3, but not 3, 4, 3. Okay, so, but that was what I assumed at first, but I did not see the sum was greater than or equal to s. I just assumed it was sum equal to s, and that created a lot of trouble for me. So the lesson that I learned was read the problem and understand what the problem is, understand the constraints. So basically, there's this idea of a sliding window, which means you have 2 pointers, a left pointer and a right pointer, and you move the right pointer right, and then if it breaks the constraint, then you move the left pointer right until it meets the constraint again. So in this problem, you would use the sliding window, and you just keep moving the right pointer right until you'll move the right pointer right, and you'll add that number to the sum, and then you see if that sum matches the constraint. So you see if the sum is greater than or equal to s. If it's not, wait, let me get this straight. You move the right pointer right, and you add to the sum. If the sum matches this, then you want to record that. Then you want to move the left pointer right until this is no longer the case. Then you keep moving your right pointer right, and then your left pointer right. This should make more sense when it's in code though, so let's just start coding. You'll want to have the left pointer and then the right pointer, and you also want to have that intermediate sum. So the sum, and then you would also need to have, because we want to return the smallest length, so we want to have a value that holds the value that we're going to return, or a variable that holds the value that we're going to return. So int, I'll call this min length, and so what should we set min length to? If we set it to 0, then every time we compare 0 with the length that we find, 0 is always going to win, right? Because it's an array of positive integers. So instead, I'm going to set it to nums.size plus 1. Basically an impossible length, so that at the end, if this is still the minimum length, then we return 0 instead. So then down here, that's what I'll do. Return min length equal to so basically this is a ternary. If it's still that, then I'll return 0, otherwise return min length. Okay, now we're ready to do the sliding window. So I do for high equal to 0, which I already set, so we just leave that empty, while high is less than nums.size, high plus plus. And then within that, first of all, we need to add this number to sum. So sum plus equals nums at high. Then we want to check, well, while the sum is greater than or equal to s, then we first want to record that, then we want to move the window over. So min length equals the minimum of the previous min length and high minus low. But then whenever you're dealing with indexes, you want to make sure that you don't have it off by one error. So let's say high is 1 and low is 0. If high is 1 and low is 0, high minus low will equal to 1, but what you actually want is 2 because that's the length, right? So then over here you'll need to plus 1. And then down here, then you want to actually move the left pointer right, so low plus plus. But before that, you need to subtract the sum subtract the number from the sum. Okay, and I think that should be it. It's like a really simple algorithm. While I was doing it, I had this concern, like what if you have this array, right? And let's say your number is 3, and then so low and high are both going to be here, and when you add low over here, high is still going to point to 3, but low is going to point to 4. That's kind of weird, right? But after this iteration, high is going to plus 1, so then low will equal to high again. Okay, and I'm just going to submit this. Wrong answer. Okay, well, what happened? So I have a low, I have high, some. Oh, oops. I didn't write that outside the while loop. I didn't write that inside the while loop. Alright, so it accepted. Yeah, so I think this is a really good pattern to have in your toolbox, I guess. The sliding window. I'm trying to think of like any other problems that incorporate the sliding window, but none come to mind right now. But I'm pretty sure if you Google sliding, actually let's do that ourselves. Okay, sliding window problems. See, so there's like a whole list of sliding window problems, including how to repair one. Yeah, so basically this is like a good pattern to know, and once you know it, you'll be able to see when you can incorporate it. And like I said again, I literally did this problem like an hour ago or like 30 minutes ago, and it was just so frustrating because I just did not read this carefully. So then when my code broke the test case, I was like, this makes no sense, and then it just sent me down the completely wrong path. But yeah, so if you have any questions or if you want me to clarify anything, just leave a comment and I'll get back to you. But yeah, thanks for watching. Oh.